Welcome, everyone. Today, we are diving into DeepSeek-V4, exploring the architecture behind its incredible million-token intelligence. This system is a powerhouse, boasting 1.6 trillion parameters and native support for a 1 million token context. Trained using on-policy distillation, its reasoning engine is truly built for the next generation of AI tasks. Let's take a look under the hood. Let's talk about what we call the 1M-Token squeeze. Compared to our DeepSeek V3.2 baseline, the V4 architecture is incredibly efficient. The V4 Pro model requires only 27% of the single-token inference flops and just 10% of the KV cache. V4 Flash is even leaner, needing only 10% flops and 7% KV cache. We achieved this massive reduction through FP4 indexing, CSA and HCA compression, and a hybrid BF16 and FP8 storage system. Looking at the V4 lineup, you can really see the leap in capability. While the version 3.2 baseline had 671 billion parameters and a 128K context window, V4 Pro scales up to 1.6 trillion parameters, with 49 billion activated, and natively handles 1 million tokens to deliver maximum frontier intelligence. On the other hand, V4 Flash, with its 284 billion parameters, is purpose-built for high-efficiency complex reasoning. So, how do we decouple sequence length from compute? The secret lies in our hybrid attention architecture. By combining a compressed sparse attention, or CSA, funnel for local dependencies, and a heavily compressed attention, or HCA, funnel for extreme global compression, V4 completely breaks the quadratic attention bottleneck. This makes 1 million token contexts computationally trivial. To stabilize this massive 1.6 trillion parameter MO stack, we introduced two major innovations. First, manifold-constrained hyperconnections, which use spectral norm bounds to guarantee stability and prevent blowouts in deep networks. Second, the Muon optimizer, which achieves faster convergence and orthogonalization without needing QK clipping. Both of these run on a heavily optimized FP4 quantization-aware training framework. Our training pipeline happens in two phases. Phase 1 focuses on forging the domain experts. Starting with a base model pre-trained on 33 trillion tokens, we isolate specific domains like math, code, logic, and agentic tasks. We optimize these using group relative policy optimization, guided by a generative reward model that acts as an automated quality inspector inside each domain. Phase 2 is the Multi-Teacher Logit Beam. Through on-policy distillation, we unify the physical expert knowledge from our math, code, logic, and agentic teachers into a single student model, DeepSeek-V4. By retaining the full 100K plus vocabulary logits, we ensure highly stable gradient estimates, transferring this knowledge without the degradation usually seen in traditional weight merging. For developers, V4 offers precise control over reasoning efforts across three distinct modes. Non-think mode provides fast, intuitive responses for an 8K context. High mode expands to a 128K context for conscious logical analysis and complex planning. Finally, max mode unleashes up to a 384K context for exhaustive stress testing, hypothesis rejection, and boundary-pushing reasoning. V4 also introduces persistent agentic memory. By leveraging the 1 million token context, the model retains a cumulative chain of thought across long-horizon workflows. This means thinking blocks interleave seamlessly with tool calls and tool results, turn after turn, without ever flushing the problem-solving state. When we look at the frontier scorecard, V4 Pro Max sets a new absolute standard for open-weight models. It systematically matches or beats leading proprietary models like GPT-5.4 and Claude 4.6 on reasoning and coding tasks. In fact, it even ranks 23rd globally against human competitors on Codeforces. In terms of real-world enterprise utility, V4 dominates white-collar tasks, showing a 63% non-loss rate against Claude Opus 4.6. It excels in software engineering, resolving 80.6% of tasks on SWE verified. Additionally, our special tokens for quick instructions eliminate redundant pre-filling, massively reducing the time to first token by reusing the existing KV cache. Ultimately, DeepSeek-V4 redefines the landscape. It doesn't just push the intelligence frontier upward for complex reasoning, it radically pushes the efficiency frontier outward, successfully decoupling frontier cognitive capabilities from exponential compute costs. To summarize, DeepSeek-V4 is system validated. It delivers a 1 million native context enabled by hybrid attention, operates at just 27% inference flops thanks to FP4 compression, and achieves frontier reasoning forged via on-policy distillation. The barrier to ultra-long context AI is gone. The next paradigm of test time scaling is here. Thank you.